first principles. So it's the limit as h tends into 0 of f of x plus h minus f of x, everything divided by h. So this part here, f of x plus h, we just take in the function itself, right? F of x, and everywhere where there is x, we put x plus h, and then minus f of x, we just subtract f of x. There's nothing special we're doing. So f prime of x will be equals to the limit as h tends into 0 of our function is x squared plus x, right? So we're gonna have x plus h in place of x, right? And then here again we're gonna have x plus h, and then we subtract f of x, the function itself, right? So we say in minus x squared plus x, and then we can divide everything by h. So f prime of x will be equals to the limit as h tends into 0 of, so we have x plus h squared, so x multiplied by x, that is x squared, and then x multiplied by h, that is xh. You multiply that by 2, you get plus 2xh, and then h by h, that is just h squared, right? And then plus x plus h, and then minus x squared, and then minus x, and then everything being divided by h. It should be easy to see here now that x squared minus x squared, so that's gone, right? And then we have x, and then we minus x, so that also disappears. So now we have f prime of x being equals to the limit as h tends into 0 of 2xh plus h squared plus h divided by h. So right now we're gonna take h as a common factor on the numerator, right? So we're gonna have the limit as h tends into 0 being equals to h. We have 2x, and then plus h, and then plus 1 divided by h, right? We just took h as a common factor. It's easy to see now that h in the denominator will cancel out with h on the numerator. So now we just left with 2x plus 1, right? And that's exactly what we're expecting, because if you derivate x squared plus x using the power rule, you expect to get 2x plus 1. Now let's do 7.2. 7.2 is quite straightforward, right? It says that let's find f prime of x if f of x is equals to 2x to the power 5 minus 3x to the 4 plus 8x. We're using the power rule, right? We know fully well that the power rule is saying that the derivative of x to some power n should be equals to nx to the power n minus 1. So if we apply this here, we're gonna get f prime of x being equals to 2 multiplied by 5, and then x to the 5 minus 1 minus 3 multiplied by 4, and then x to the 4 minus 1, and then plus 8 multiplied by 1, and then multiplied by x to the 1 minus 1. That should be equals to, so we have 2 multiplied by 5, 2 multiplied by 5, that is 10, and then 5 minus 1, that is 4, so we have 10 x to the power 4, and then minus 3 by 4, that is 12, and then x to the 3, 8 by 1, that is 8, and then x to the power 0 is 1, right? And the number to the power 0 is 1. And just like that, we already have 8 marks. And now let's do 7.3. So 7.3 is saying here that the tangent to g of x, if our function g of x is equals to ax cubed plus 3x squared plus bx plus c, has a minimum gradient at the point minus 1 and minus 7, right? For which values of x will g be concave up? For which values of x will g be concave up? I think if there's one thing we can agree on here is that this question will be extremely easy if we knew the value of a and the value of b, and then maybe I forgot plus c here. So maybe, you know, let's give it a try. Let's see if we can find ABC. If we find ABC, then we're just gonna derivate twice, equate to 0, and then we're gonna be able to find for which values of x will g be concave up. So let's, you know, go ahead and look at our equation and see what we can do here. So we can see here that the tangent, right, to g of x. So the tangent to g of x, let's find the equation of that tangent. So we're saying that g prime of x, we're trying to find the tangent to that graph. That will be 3ax squared, we just applying the power rule, right, plus 6x plus b, right? So now we have this tangent, right? Let's go ahead and substitute that point, -1 and -7, and see what we can do here. So if we substitute -1 and -7, we're gonna get -7 being equals to 3, and then a, and then -1 squared plus 6 -1 plus b, right? So we have -7 being equals to -1 squared, that will just be 3a, and then -6 plus b, right? So we can go ahead here and make b the subject of the formula, right? So that we don't have to divide, because if you make a the subject of the formula, you're gonna have to divide both sides by 3, and we don't want to do that. So if we do that, we're gonna get -7 plus 6, that will be -1, and then we take 3a to the other side, we get -3a being equals to b, right? So this is our equation 1, because you can see now we have 2 variables. So we need to think of another way we can use to find another equation, and then it will be straightforward. We are going to use the fact that -1 and -7, we find the minimum gradient of this graph here. We find the minimum gradient of this graph. So we can derive that equation again and equate to 0. Let me show you what I'm talking about. So we can say that g prime of x basically is equals to so if we derive that, that will be 6ax plus 6 being equals to 0, right? That's where the minimum gradient is. Minimum gradient is equals to 0. So again, we know the x value of that point, it is -1, right? So we can substitute that -1 in our equation. If we substitute that -1 there, we're gonna get 6a -1 plus b is equals to plus 6, not b, plus 6 is equals to 0. So here you're gonna see that -6a is equals to -6, so a is equals to 1. Right? So now we have determined that a is equals to 1. Now let's go to equation 1, to this equation here, and substitute 1 so that we can find b. If we do that, we're gonna say -1 minus 3 multiplied by 1 is equals to b. -4 is equals to b, right? So now we have the value of a and we have the value of b. Let's substitute them in our graph g of x, right? Because like we have already agreed on, if we find a and b, it becomes extremely simple to find for which values of h will g be concave up. So now we're saying that g of x is equals to, in place of a, we put 1 and then x to the 3, right? And then plus 3x to the 2 plus bx. So we know that b is -4, so -4x plus c, right? So now we have g of x is equals to x cubed plus 3x squared minus 4x plus c, right? So now we have this equation here. The only unknown variable we have is c, but then c doesn't really matter, right? It won't affect us with much, because for us to find the x value at the point of inflection, we have to derive twice, and when we derive twice, c is gonna fall apart, right? Because for us to know for which values will g be concave up or down, we need the x value of the point of inflection, right? I can tell you already that that x value will be -1, because that's where the minimum gradient of the tangent is. But you don't have to believe me, let's just work it out. So if we derive this twice in attempt to find the point of inflection, we're going to say that g prime of x will be equals to 3x squared plus 6x minus 4, right? And then we derive it again, we get 6x plus 6, right? And then this is equals to 0. So it should be easy to see now that x will be equals to minus 1, right? So our point of inflection is minus 1. Now let's look at our graph g of x, right? The coefficient of x to the power 3 is positive. If the coefficient of x to the power 3 is positive, our graph should look like this. So this is how our graph will look like, right? And we're saying that our point of inflection is somewhere here at minus 1, right? We're looking for the values of x, of which our graph g is concave up, right? So this is concave up, right? Because our graph is ultimately going up. So when x is greater than minus 1, our graph is concave up.